Welcome everybody to example 6 on page 103 of the workbook. And this is another example of calculating a definite integral using the fundamental theorem of calculus. Okay, now before we start this problem, I want to just point out that we've got a graph of the function that we're integrating sitting over here on the right. And before you watch the rest of this video, I'd like you to think about one problem. Okay, can you predict whether the value of this integral is positive or negative based on the graph here? And I'd like you to maybe pause the video, just give that a little bit of thought, see if you can come up with a conjecture, and then continue with the video. Welcome back. So hopefully you spent a little bit of time thinking about whether this integral is going to be positive or negative. Okay, so I'm hoping that what you might have thought of is the fact that an integral is about area. So this integral from 1 to 4 that we're calculating has to do with these areas that I'm shading. Notice that part of the area is above the x-axis and part is below. Which area looks bigger to you? Looks like we've got more area below the x-axis than we do above, and so that should mean that the value of this integral is negative. All right, so let's see if we can calculate this integral and confirm that conjecture that we made. Okay, well, the function that we're integrating in this case, you might have noticed, is pretty complicated. And so 10 minus 5x over the square root of x, that's a quotient. We do not have a quotient rule for antiderivatives. And there's nothing on the table of common antiderivatives on the previous page that would help us. This function is just too complicated. So to have any possibility of doing this problem, we need to rewrite the function that we're integrating. So we'll start by seeing if we can do that. So we'll start with the 10 minus 5x over the square root of x that we were given. And I'm going to remind you of the fact that the square root of x as a power is really x to the 1/2. So what we can do is take that x to the 1/2 and move it into the numerator. And that allows us to take this x to the negative 1/2 and distribute it through. Just multiply it through that set of parentheses. Let's do that and see what happens. Okay, so 10 times x to the negative 1/2, that's the first term. It's going to look like just 10x to the negative 1/2. What about the second term? Okay, well, 5x is really 5x to the first. And so we need to take x to the first times x to the negative 1/2, which means we're going to be adding the exponents. And if you take 1 plus negative 1/2, you're going to get x to the 1/2. Oh, and I just noticed this should be a minus there, not a times. Okay, so we've rewritten our function as 10x to the negative 1/2 minus 5x to the positive 1/2. Okay, so we're hoping that that way of rewriting our function is going to lead us to an easier calculation of the integral here. Now let's check it out and see if that works for us. So the integral from 1 to 4, we've reduced our function down, or rewritten it, as 10x to the negative 1/2 minus 5x to the 1/2. Okay, and the first step to doing that integral is to get an antiderivative for our functions. All right, so I'm going to start by rewriting the 10, and what we need now is an antiderivative for x to the negative 1/2. Notice that x to the negative 1/2 is a power, so we should be able to use the power rule. And remember how that works again. The power rule says we're going to take the old power of x and add 1 to it. So we're going to take negative 1/2 and add 1. That's going to give us 1/2. So we're going to get x to the 1/2 and then divide by the new power of 1/2. There's the antiderivative. Okay, then we come to the next term, minus 5, and now we need an antiderivative for x to the 1/2. So if you take the power of 1/2 and add 1 to it, you're going to get x to the 3/2. Okay, and divide by the new power. There's our antiderivative, and we need to evaluate between 4 and 1. Okay, but these two fractions that we have, x to the 1/2 over 1/2 that looks a little bit ugly the way that we have it now. So we're going to make an observation that if you divide by a fraction like 1/2, that's the same as multiplying by the reciprocal. So we could rewrite this as 10 times 2 over 1, which is 2, times x to the 1/2. That looks nicer than dividing by 1/2. And we can do a similar thing over here to the right. Dividing by 3/2 is the same as multiplying by the reciprocal of 2/3. Okay, we're going to evaluate between 4 and 1. Okay, and I'd like to do one more thing before we substitute our numbers in. So 10 times 2 is 20, x to the 1/2. And then 5 times 2 over 3 is 10/3, x to the 3/2. And at this point, we'll go ahead and substitute in our limits, 4 and 1. Okay, so starting with the upper limit of 4, we substitute that in. We're going to get 20 times 4 to the 1/2 minus 10/3 times 4 to the 3/2. There's our upper limit. And then we'll substitute in 1. And notice that when you substitute 1 into x to the 1/2 and x to the 3/2, you're going to get 1 because 1 raised to any power is 1. So we're just going to get a 20 minus a 10/3 out of those last two terms. Okay, so we're almost there. So we've got a couple of numbers to calculate here. Notice that 4 to the 1/2 is just 2. And 4 to the 3/2, you may be able to do that calculation by hand. You could also ask your calculator if you wanted to, and it will tell you that that's going to be 8. Okay, if we fill those two pieces in, we're going to get 20 times 2 is 40, minus 8 times 10/3 is 80/3. And let's go ahead and subtract. Actually, we don't need those parentheses. Let me get rid of those. So 40 minus 80/3. We'll go ahead and distribute that minus sign through and get a minus 20 minus a negative 10/3 is a plus 10/3. Okay, and then maybe combine the 40 and the minus 20. That's going to give us a 20. And then minus 80/3 plus 10/3. That's going to be a minus 70/3. Get a common denominator here, and that's going to be 60/3 minus 70/3, which leads us to an answer of negative 10 over 3. Okay, now I want to make a couple of comments on that answer. First of all, way back at the beginning of the problem, we wanted to make a guess as to whether this integral is positive or negative, and we decided that it should be negative based on the area. So notice that our answer is negative, so that's a good sign that maybe our answer is right here. Okay, another thing that I'd like to point out is make sure you're aware that this is an exact answer that we just found. So that negative 10/3, there's no error involved in that. That's very different from the situation back in section 4.2 where we approximated integrals using rectangles. All of our answers there were estimates, but this represents the exact difference of areas, okay, that we shaded up here in our picture. Okay, so the fundamental theorem of calculus is a very powerful tool. It allows us to find the exact value of definite integrals.